Okay, this is another example taken from WAEC 2004 number 10A. It's a theory question and it's still on latitude and longitude. Okay, let's study it together and solve it together. The question says we have a point K. K is on latitude 60 degree north and longitude 50 degree west. Okay, so it's a point on the Earth's surface, okay. Then L is another point. Then where is L located? Located due east of K. No information is given, no latitude, no longitude. Okay, and the third point N is due south of K. So there's another point N which is due south of K. Okay, from K now is due south. When they say due south, that means from K you just come down south. Just like L is a point due east of K. That means from K you move east. So that is what we do in the sketch. That will still interpret the drawing using the 3D and the normal solution page that we are going to use to work with. So the distance KL is given and distance KN is given. Then we should calculate longitude of L and latitude of N. You can see K and N, no information is given, no latitude, no longitude, and that's what the question wants us to calculate. But as long as we have the distance between K and L and K and N, this question is not difficult, because you know that in your distance formula you need to do theta over 360. And what is theta? Theta is always the angle between the 2 points. So the angle between K and L, if I can get it, then from there we can get our latitude and longitude. So it's not a difficult one, but we need to understand the sketch of this question first. So let's look at our 3D view. Let's study the question very well. So as usual, this is our Earth, the sphere, the North Pole, the South Pole. This is the equator. You can see it clearly. Then this is the Greenwich meridian. Both of them meet at this point, which forms the 0 degree line. That's our reference point. So let's start with what the question says we should do. Okay, let's locate point K first. K is standing on latitude 60 north, longitude 50 west. So let's locate that point K. Okay, let me start with my point. I have a point here. Okay, then let me put the latitude. Then this is the latitude. Okay, let me have another point. Put this point. Okay, let me put the longitude. This is the longitude of this point. Okay, alright, so this point, this is what I'm going to name as K. So what I'm going to name as K. Then this is K. Then point A. Let me hide it, I don't need it. Okay, then let's put the other angles that we will need. So we have our line from point to 0. Okay, then we need our small radius line, which is this. Okay, let me hide this also. Okay, so I need my small radius line. So from this point, so this is our small radius line. Okay, then let's put our angles. Angle between reference to here. Angle between reference to here. Okay, so this is the interpretation of this question. This is the interpretation of this question. This is point K. Okay, and this is the first point. Okay, so the question says, let's see it again. Point K is standing on 60° north. So 60° north, that means K is rising up. You can see as I'm moving it up, you can see K is rising up, and this angle, it says 60 degrees. So you see it's going up towards north. You can see it's going towards the north. Until we get to 60 degrees, we stop. Okay, 60 degrees. So K is on 60° latitude. You can see the small circle. Then on the west side, 60° now, it now move 50° towards west. So this is the point K now. See, this is the angle. Let me put it where you can see it clear. This is the angle of K. So it's now on 60° north. You can see point K. It rise up 60° north. Then it's now moving west. And the question says 50° west. So you move. So 50° west. This is the angle. 50° west. So that is position of K. So this is point K. So no problem with this. Then the two other information in the question says L is another point due east of K. Due east, one information you should take note here is if L is due east of K, that means east is on this side. This is east, this is west. Remember our cardinal point. East is on this side, west is on this side. So now K is already 50° west. So L is due east. So on this same line, that's what they mean by due east. It's on this line, somewhere on this edge. That is where L is standing, but we don't know the exact point. So let's just put any point somewhere here. Let's assume this is the point, but the angle is not given, so we cannot assume an angle for point L. We can't assume an angle for point L. Even this position for L, you can't say if it's on east or west. That's another thing you should take note of. You can't really say L is standing like what I did in my sketch here. I put L in east. It's possible when they say due east, it's possible it's somewhere here. L can be somewhere here. If it's here, it's still due, it's still west, but due east of K, but on the west side. You understand what I mean? If I put my L on this place, L is still on the west side of the earth, but east of K, due east of K. So that is one thing you should take note. L can still be here. We can put our longitude so that we can see it clearly. So put your longitude, you can see it. So this is the point L. You can see L due east of K. Just take note of this. Okay. See it, but the one that we know the information is that of K. Everything is balanced in this place. Take note of this. Okay, let's go back to the question and see the next point, which is point K. Okay, no, that is point N. It said the third point N is due south of K. So let's locate point N now. So this is K, N is due south of K. So if I have a point, let me place the point here. Let's call it N. This is the point. Let's call it N. Okay. So you can see point N very well. So this is point N. N is due south. No, south is downward. So still on the same line with K, on the same longitude, but it will come down to south. So take note of this. It's not up. If it's up, this is towards north, but it's below K, which is south. But we can't say if it's on the north side of the sphere. If N is somewhere here, that is it's on the north side. Let me put the latitude so that you can see it well. So this is latitude of point N. So this is latitude of point N. If it's here, it's on the north. But if it goes below the equator downwards, so N is south of the Earth. But the most important thing is on south of K. It's not above, it's below it. If it's above it, it will be on top like this. But the question did not say north of K, it said due south. So N can be somewhere here, it can be below. So it depends. Until when we are through with our calculation, we can now decide where N will truly be, either here or here. Okay, so this is the analysis of this question. You can see the 3D view. I think you are getting the picture very well. When this kind of picture, you have the true picture in mind, the question will be easy for you to solve. And the angles especially will not be difficult for you to interpret. So let's go and solve the question here. Let's see. You get your compass, you make your circle, then you get your middle, don't forget that. Get your ruler, get your center for the equator, then you turn it, get your prime meridian line, then this is your north, this is your south, this is your east, then this is your west. So by the time you get this, we start, says 60° north, you come up, you make your curve, always label, very very important, 60°, 60° north. Then it says 50° west, so you go like this, also label this 50 degrees west. Okay, so where they meet is the first point, we call it point P. Take note of this. Then the next part of the question says L is on due east of K, which is east of K, that is L. Okay, and we don't know the longitude, but since it's due east of, okay, wait, let me see the labeling. Okay, that is K, not P. This is K, not P. This is K, not P. Okay, so L is due east of K. That means they are standing on the same latitude. So let's just assume L is somewhere here. Let's assume L is somewhere here. Let me label it down on this side. So this is L. This is point L. Where it made the latitude is point L. Then the angle, since we don't know the longitude is the major target. We know the latitude now. The latitude is 60°, but we don't know the longitude. So let's just take beta as the longitude. Let's call it beta. Let's call it beta degrees. But you can't say if it's east for now or west until you are through with your calculation. But we know that it's due east of K. Just leave it beta degree for now. Then the other point, which is point N, which is due south of K. N is due south of K. We just bring it down. It can be here, it can be below, but let me just put it below. We'll still know when we are through. So it can be here. So you only know the longitude of N. So this is point N, where it meets the longitude. So this is point N, but you can't say if it's on the west south side or on the north side. But let's just give the angle a name. Let's call it angle alpha. Let's call it angle alpha. But you can't say north or south until you are through with your calculation. So this is the sketch you have down on your paper. And now let's go to our calculation and see what we can do to get the two answers we are solving. So the first answer says we should find this, the longitude of L. But let's start with distance KL first. We all know that KL is given distance KL. Distance KL is given as 3,520 kilometers. So since distance KL is given, so we can start our calculation from here. Okay. Sorry, let me number it. I want to number it. Okay. So this is a calculation for A we are doing now. Okay. This calculation for A. Okay, so distance KL is this, and our formula for distance. Take note, KL is standing on a small circle. So our distance formula we are going to use is the small d. So KL, let's just put it there now. KL will be equals to theta divided by 360 times 2 times pi 2 pi r. So you are using small letter r because it's standing on a small circle. So take note of that. Then now, what is the angle? This theta is very, very important. Remember, theta is angle between the 2 points. So angle between K and L. So how do we get angle between K and L? So we don't know it now. You can see from the sketch we don't know the angle between K and L. Sorry. Okay, we don't know the angle between K and L. So how do we do that now? Okay, I'm looking at this north pole. This north is the latitude. Sorry, I'm looking at it as the longitude. So we don't know the angle here. So notice what we need to do. This is what I'm talking about. So this is the angle we are looking for. We don't know the angle between K and L. We know that from 0 to this point is K. You understand? But now from 0 to L, we don't know it. So let's solve theta. Whatever we have as theta, we'll know. If it's greater than 50, we'll know that it's on opposite side, and we are going to subtract 50 from it. But if it's less than 50, we are going to add. It just depends. We'll know that. So this is the theta. So let's find this theta. After getting theta, we'll now check. From 0 to K is 50, 0 to L, then we can now subtract or add depending on the value we have. So theta will now be what? Let's solve for. Before we solve for theta, let's get our r, the small letter r. Remember the formula, capital R cos alpha, and alpha we said is the latitude on which both points are standing, which is r is given as 6,400. This is the capital R, then multiplied by cos. The angle, the latitude is 60, multiplied by cos 60. So cos 60 is 0.5. This one will not take our time to evaluate. You can see use your calculator and check it. Cos 60 is 0.5, then 0.5 times 6,400 will give us 3,200 kilometers. You can still check it with your calculator in case you are doubting. Times cos 60. You see your answer will be 3,200. You can see it there. So 3,200 kilometers. Then finally KL. Let's substitute and get our theta. KL is 3,520. Then it's equal to theta we don't know, divided by 360 degrees times 2 times pi is given at 22/7 times 6 r, which is what we have calculated now, 3,200. Then we need to simplify this now. We need to simplify this and get our answer. Okay, how do you do this? You can multiply the numerator. Let's multiply the numerators first, which is 2 times 22 times 3200. Let's put it in decimal. Okay, which is this. Then 360 times 7. 360 times 7. Let's put it in decimal. As I multiply the denominator 360 times 7, then the numerator 2 times 22 times 3200. So it's going to give us 3520 is equals to 140,800 theta, then divided by 2,520. So this is what we got here. Okay, let me move down a little. Then we can finish our work here. If I cross multiply and divide by 140,800, I will get my theta. So without wasting time, theta will now be equals to 3,520 times 2,520 divided by 140,800. So theta will now be equals to, so let's simplify this one. Let's simplify this and see our final. So let's simplify it here. 3,520 times 2,520 divided by 140,800. So we got 63. You can see our answer is 63 degrees. 63 degrees. So this is where we need to check if it's going to be in north or in south. Let's go to the diagram and see. So if theta is 63, so we are talking of angle between K and L is 63 degrees. Let's see if this angle is 63. Remember, K is on this side of the question. K is on the west side, which is 50 degree west, and L is on the east side of K. So if we say it's 63, that means from here to 0 it's already 50. You see now, so 63, that means this sketch is correct. You can see, you understand what I'm saying? From 0 to K is 50 degree west. You can see 50 degree west. Then the angle between them is, we got it at 63. So this is already 50. When you keep counting, 51, 52, 60, 63. So now do you get this small angle from 0 to K? This is what we need to get now. How do you get it? All you just need to do is you subtract now 60 minus 50. Sorry, 63 minus 50. Whatever we get will be the remainder. So that means this angle is, the final answer will now be like this. Remember the symbol we use. We say let beta be the longitude of L. You can see it. So it's the longitude we are trying to find now. So finally you can now say beta. You can now say beta, which is the longitude of L now, will now be equals to, I will position it well. Beta will now be equals to 63 minus 50. And the answer is going to be 13. 3 minus 50 will give us 13, and that 13 is going to be 13 degrees east. So this is our longitude of point L. Longitude of point L. So let's check. So this is what I'm saying. If this place is 50, this place is 50 degrees, understand? Then this other side is 13. Understand what we are saying? The angle from 0 to L now is 13. The angle from 0 to K is 50. So 50 plus 13 will give us the angle between both of them. And remember we got 63, so 50 plus 13, see, we are getting 63 as our answer. So the angle between K and L is 63. You can see how you interpret such a question. So take note of that. So that is the first answer. So take note of that. K. So the longitude of L. So you calculate the longitude of L. The longitude of L is 13 degrees east. Take note of that. You can put it in words if you want to put in words. So you can put it in words. Longitude L will now be equals to L will now be equals to 13 degrees east. So that is that. So that is the end of the first solution. Okay, let's go to the next one now. So the next one says, which is the B part of the question, say we should calculate the latitude of n. Okay, so the distance is given, kn is given. So this one will help us in our solution. So distance kn is equals to, we have it there, 10,951 kilometer. So 10,951 kilometer. So let me number it also. This is the B part. This is the B part for calculation. Okay, let's see how can we get the longitude. Okay, we said in the sketch the other time, K and N, they are standing on great circle. So we just use capital R as our radius. But the major challenge now is the angle between them. Remember, the angle we need is this angle. The angle that goes to the center of the earth. So this is the angle we need, and the one that comes to the center. So this is the angle we need. Just like this other case, this is the angle we need. So now we need this angle, this full angle. Okay, let's still call it theta in our calculation. Since theta is always angle between the 2 points, let's call this angle theta. Then now depend, whatever answer we get, the way we did this analysis of this one to check if it's east or west, that is the same thing we are still going to do if it's north or south. So let's get this angle first. From there we'll know what to do. So the same thing now, Kn will now be equals to theta over 360 times 2 times pi r. So the r should be capital R, but they are standing on great circle. Okay, so Kn is giving us 10,951 equals to theta is what we need to get now, divided by 360 degrees times 2 times pi is 22 over 7 times radius is giving us 6,400. So without wasting time, let's cross multiply. Okay, let's do the same way we did the other one. Let's times 2 times 22 times 6,400. 2 times 22 times 6,400. Getting this, let's put it in decimal. Yes, then 360 times 7. 360 times 7. So let's also put it in decimal. Okay, so we have 10,951 is equals to, so the first one is 2,800 okay, 281,600 theta, divided by 2,520, which is 360 times 7, 2 times 22 times this, we get that. Then the next thing, let's cross multiply. So theta will now be equals to, so 10,951 is going to multiply 2005.20 when you cross multiply, then divide by 281,600. Oh, sorry. Which is 10,951 times 2,520 divided by 281,600. Okay. So when we do this directly, we'll get our answer. Let's just do it here with our calculator. 951 times 2,520 divided by 281,600. So you can see our answer 97.9999. Let's just take it to 98. Let's take it to 98 degrees. Because it's very close to 98. So theta is equals to 98 degrees. Theta is equals to 98 degrees. Okay, now that theta is 98 degrees, let's check. This is where we need to know if the point N we need now, if it's on the east, if it's on the north side or on the west side. So the angle between them, we got 98 degrees. Let's look at our diagram. So this angle is 98 degrees. So let's see. So if from 0, this is our 0 line, from 0 to K, you can see the angle from 0 to K, which is this one here, is 60 degrees. So this is 60 degrees. You can see from 0 down to K is 60 degrees, which forms this latitude, 60 degrees. And now we are talking of the full angle between both of them. We are getting 98. That means N is truly on the south side here, which is what we call alpha. That means it's correct. So if the full angle here is 98, so 98 minus 60 will give us the remaining angle. So we are in order. So finally now our alpha will now be equals to 98 minus 60, which will be equals to what now? 98 minus 60, what will it give us? Let's subtract. So 8, 9 minus 6 will be, so this will give us 38 degrees. So 38 degrees south. So it will give us 38 degrees south. Let me move down a little. So final answer now, you can put it in words so that you can see it clear now. You can put it in words now, which is latitude N now be equals to latitude N will now be equals to 38 degrees south. So that is it. So how do you know that is south? Let's go to the diagram before we end the question. So we got here as 38. So take note of that. So what we are saying is 38 plus 60. You know, this is the full angle now between K and N. So 38 plus 60, you can see we got 98. 8 plus 0, 8. 6 plus 3, 9. So 98. So when you subtract 60 from 98, you got 38. So from 0 to N is 38. From 0 to K is 60. So this is the angle between K and N. Then the angle between K and L. So if you look at this, my explanation, look at the sketch very well, follow the study, you see that this question is truly not difficult. But you just need to know this topic very well from the scratch and follow all I did. So these are the two answers they asked us to calculate. Longitude of L, 13 degrees east. Latitude of N, 38 degrees south. So that is WAEC 2004 number 10A theory question. You know, this is a theory question, so you need to solve it well, and that is why it's somehow long like this. But if you practice very well, this question won't take you more than at most 15 minutes. You are through with solving this question when you practice it very well, and similar one comes out like this in your exam question. So take note of this, and that is